Recording. No, what's that? Yeah. Okay, start recording. Yeah, I forgot to start the recording. Okay. So, every PLC also provides some timers, but the timers depend on the brand. The detail of the timers are different. For example, the Siemens, the detail of the instruction of the timers in the Siemens is different from Allen Bradley, different from Omron, and some other any other PLC. So it is important that depend on the PLC, we check the instruction detail and study the instruction of that type of PLC. Okay, there are many benefits to use timers in the PLCs. We can simply change the settings, the times, or any others. The operator can just type the timer at any time that they want to change. Generally, there are many timers available for each CPU. So, depending on the CPU, we should check the user manual of the CPU to be sure that how many timers is available for that type of CPU. But generally, it is sufficiently large. Depend. For small scale, for compact PLCs, maybe just a few tens, but for larger scale applications, for PLCs, advanced PLCs, CPUs, they have even hundreds of timers available in the programming. So there are lots of them, and we don't pay any money for them. When we have the PLC, we have all those timers. We don't need to buy them one by one. We have all of them, and so simply we can use them. Also from the accuracy, because those mechanical, especially mechanical and electrical and even electronic type of timer contactors, after many months or many years of using, little by little, the mechanical or electrical devices loses some of the properties, or the properties change slightly, and as a result, the timer does not calculate the time exactly as it was set, or even sometimes the temperature has effect on them. But for the timers in the PLC, there's no change. The accuracy is complete. They're very accurate. Okay, so let's have a look to the timers in the Allen Bradley, in the Siemens PLC. What's that? The Siemens timers are available in the instruction. Let me open the TIA. That might be better. So look at that over there. Okay, meanwhile, so the PLC, Siemens PLC has four type of timers. It's called pulse timer, on-delay timer, off-delay timer, and on-delay retentive timers. Each timer has some inputs and some outputs, and also the name and the data file of that. So each timer has some inputs, some outputs, and also we should assign some name on them. Okay, let's open a new project. Let me open one of the previous projects, like this one, for example. Yeah. To save the time. It takes time. Okay, let's have a look to the some detail, and then we'll look at that. Okay, then we select the timer. We can change, assign some name to that. I don't know why it is too slow today, my computer. Okay. Oh yeah. Yeah. So on the program, this, okay. Okay. So this is the previous program that we used in the last session. Let me, in a new network, add a timer. Okay, where's the timer? Here under the instruction, here, click here. Oh, sorry. Under the instruction, it is open. Sorry, yeah, it is open. So here you see that timer operations. Okay, and then these are the timers that are available. Pulse timer, on delay, off delay, and when we select one of them, okay, double click on that and then, or you can drag it. Yeah. Okay, then when we select one of them, for example, this pulse timer, the first thing that it asks is if you want to change the name of that. Let's call that timer 1, for example, just as an example. Some titles are not acceptable because they are reserved for PLC program. For example, the timer itself, just timer, cannot be set as the name, as a title or the name of the timer. But timer number 1, that's okay. Every timer needs some data. There are some data associated with each timer. All of them are saved somewhere that is called data block. For each timer, we have a data block. The data block for that timer is somewhere that all the information regarding this timer is saved over there. By default, the TIA automatically assigns some number, data block number 1, for example. If the data block number 1 is used for another timer or another instructions that need data block, it automatically gives you number 2 or number 3. The first available data block. You can change that manually if you like, but I prefer not to do that. I prefer to keep that as the default, so there's not any conflict, but it's up to you. So you can, we can open that. And here you see that, okay, timer number 1, data block number 1. So timer, this is the title and this is the data block. Any timer has a digital input, a digital output, a preset time, and an elapsed time. Okay, what are they? They depend on the timer. All of them has these 2 input and these 2 output, but depend on the timer, maybe they have an extra inputs. To see what are they, let's look at here. Okay, input instruction. In fact, the input instruction is the input that activates the timer. So every time that the input instructions is 1 or change from 1 to 0, depend on the timer, the timer activates. Okay. So the timer activates every time that the input instruction changes from 0 to 1 or 1 to 0, depending on the timer type that we will look at the detail on that. The preset time is in fact that delay, the delay, on delay or off delay. The delay that we give to that is the preset time. The Q is a digital output that changes depending on the structure of the timer. And the elapsed time shows that, okay, from the time that we activate the timer, how long it has passed, or let's say how long elapsed. Okay, the preset time, preset time is the time that, as I mentioned, it is the delay, or on delay, off delay, pulse, or like that. In the Siemens PLC, it's very simple to assign the delay. Just the format is how many days, how many hours, how many minutes, how many seconds, or milliseconds. So simply like this, T, then the sharp, then 10 S. It means that the delay is 10 seconds. If you write like this, 1 H, underline 2 M, underline 12 S, it means that 1 hour, 2 minutes, and 12 seconds is the delay. Or, for example, milliseconds. But please notice that in the data block, the data saves as a milliseconds. So all the times the data in the data block, it shows the time, that preset time in milliseconds, but the timer itself calculates that based on the values that you give that. 1 hour, how many milliseconds is 1 hour, how many milliseconds is 2 minutes, and how many seconds is 12 seconds. So as a result, the maximum delay that we can apply or we can implement by a timer, by a single timer, is 24 days, 20 hours, 31 minutes, 23 seconds, and 647 milliseconds. This is the maximum time delay that is possible. Generally, it is sufficient, but if you need more longer delay for any reason, you can cascade 2 timers to increase the timer. So there's one timer and then another one that are cascaded, but that's not something that we need. As I mentioned, it is in milliseconds. This is the milliseconds, equivalent milliseconds of this number, of this time. Okay, what about the output? The output, there are 2 digital the outputs. One output which is digital, so it changes from 0 to 1, from 1 to 0 or 0 to 1. The other is elapsed time. Elapsed time, in fact, from the time that the timer activates and start to calculate the time, that elapsed time increases. So you know that it has not yet reached to the final delay value, the delay value that you set on the timer, but at least you know how much has passed, how much elapsed. And generally, many times we use this elapsed time to have an indicator for the operators, and so the operator knows how long has been passed from the time that the timer actuated. Especially for some of them, for some of the applications, sometimes it's needed to write down the elapsed time. But changing the elapsed time and the output, the output or the elapsed time depends on the type of the timer. So let's one by one see how they change for each of these 4 timers. Pulse timer. In the pulse timer, in fact, if you give some preset time, when the input instruction activates, when the input instruction sets to 1, from 0 to 1, the timer generates a pulse with that duration. So for example, if the preset time is, let's assume that the preset time is set that to 2t, for example, 10 seconds, okay? So then there's a rising edge in the input. The timer calculates the time, starts to calculate the time, and that value of the time, the elapsed time, is given as some number in the elapsed time, ET. But Q, immediately as this turns on, this also turns on, but it sets to 1. This also sets to 1 and remain 1 for the time that we preset, the preset time, so for 10 seconds. So it remained 1 for 10 seconds and then resets to 0. The output resets to 0, although the input is still 1. So it generates a pulse. It just generates a pulse. Generate a pulse, and after that pulse time, the delay finished, the output remains 0 until again a new rising edge. A new rising edge happens. Again, a new rising edge happens and then a pulse. The question could be like this. What will happen if before that preset time elapsed, I reset the input? So at this time, the output sets to 1, okay? If the input remain 1 for more than 10 seconds, the pulse would be 10 seconds. What will happen if it goes to 0? It remain, the pulse continues to calculate the time, the pulse timer continue to calculate the time, and when that preset time finished, ends, then it goes to 0. So, for example, if you have just a very short input, if you have a very short input pulse, the Q continues to remain for preset time, sets for that preset time, and then change to 0. So the pulse do that. The pulse timer works only on the rising edge of the timer. Only on the rising edge of the timer, and it does not, let's say, refresh if you change the input to 0 and then again to 1 during that preset time. It remains. So this is how it works. Okay, the next timer is on delay. How the on delay works? On delay is very simple. As the input sets to 1 or sets to 1, the timer calculates the time. The output remains 0. The output is still 0, does not change. But the timer starts to calculate the time. So the elapsed time increases. When the elapsed time reaches to the preset time, then the output becomes 1. So there's a delay for turning on. It is an on delay. What will happen if the input resets to 0? Immediately the output resets to 0. And also the elapsed time resets to 0. So you see that as the input resets to 0, both the elapsed time and the output resets to 0. Okay, this is the normal operation of the timer, something that generally we expect. But the question could be this again. Let's assume that at this time we set the input to 1, and so the time starts to, the elapsed time starts to, the timer activates and the elapsed time calculates. What will happen if before the elapsed time reach to the preset time, before we reach the elapsed time reach to the preset time, we reset the input to 0. For the on delay, everything resets. So again, the elapsed time resets and the Q remains 0. It does not turns 1. So everything resets to 0 and nothing will happen. So the input instruction must remain 1 at least for the preset delay time. Otherwise, if it sets to 0 earlier, everything resets and timer do nothing. The timer does nothing. So this is how this on delay timer works. This is the format of that. There's another timer on delay with retentive that is different from this. Another type of on delay, but a different from that we will look at that also. But before that, let's have a look to the off delay. The off delay is similar to the mechanical off delay or standalone off delays. Again, what happens? Let's assume that at the beginning, the input is 0 and the output is 0. We have some preset time. Then at this time, the input sets to 1. The output immediately sets to 1. You see? So immediately sets to 1. This is different from this one. You see? It sets to 1. The output sets to 1 with some delay. But in the off delay, when the input turns on, when the input becomes true, the output immediately becomes true and remain true until the input resets to 0. When the input resets to 0, then the timer starts to calculate the time. So timer does not start to calculate the time when the input becomes 1 in the off delay timer. It does not do anything. It just changes the output to 1 and wait until the input resets to 0. When the input resets to 0, then the timer starts to calculate the time. And when the elapsed time reaches to the preset time, at that time the output goes to 0. So it means that there's a kind of delay in turning off the timer. There's not any delay on turning on the output. There's a delay on turning off the output. Okay. So this is the normal operation that we expect. What will happen again? Another similar question for the special case. What happens? What does happen if? Okay, at this time we set that to 1. Okay, and the input, so the output becomes 1. Then at this time it turns off. When it turns off, when the input turns off, let's say the input resets to 0, the timer starts to calculate the time. What will happen if before the elapsed time reach to the preset time, we again set the input to 1? The timer elapsed time resets. The timer elapsed time resets, so it remains 1 and nothing happened until you have we reset the input, and then again the timer starts to calculate the time, and after that preset time delay, the output turns off. So this is the timing diagram of the off delay timer. There's a delay on turning off, and also if before that elapsed time reach to the preset time, the input sets again, the elapsed time resets to 0 and nothing will happen on the timer, and it waits for the next time that the input resets to 0. Okay. Okay, this is not correct. This should be retentive. Oh yeah, that's not a correct title. It should be on delay retentive. Yeah, on delay retentive timer. No, it was not the correct title. Okay, on delay retentive timer. What is the on delay retentive timer? Okay, for the on delay, let's look at that again. We see that if the elapsed time has not yet reached to the preset time, if before the elapsed time reaches to the preset time, the input resets, everything resets. The elapsed time resets and nothing will happen. In the on delay retentive time, the elapsed time does not reset when the input resets to 0. It keeps the value. It does not change. So it is a retentive timer. It can keep the elapsed time value and wait until again the input sets to 1. And then again continue to calculate the time. If, again, like this diagram, before the elapsed time reach to the preset time, again the input resets to 0, that's fine. The timer keep the elapsed time, does not change that to 0. Wait until again the input becomes 0, and multiple times might happen until finally at some time the elapsed time reach to the preset time. In that case, in that moment, the output becomes 1. So it keeps the time. It keeps the calculated time and there's a retentive. This is the normal operation of that. Then the question could be, okay, how to reset this system, this timer? It just increased the elapsed time. How can I reset the timer and start a new timing operation? To reset that, we need to apply a command to the reset input. So this on delay retentive timer has one extra input. That extra input is to reset that, because for the other timers, they automatically resets like this, or like this, automatically resets, or like at this moment. When the input becomes 0, the timer resets. But for this timer, it does not reset when the input instruction is 0. So it has an extra input to reset the timer. And then the timer is ready for the next operation. So there are 4 timers in the Allen Bradley, in the Siemens: the pulse timer, the on-delay timer, the pulse timer that generates a pulse, an on-delay timer that the output turns on with some delay, the off delay where the output turns off with some delay, and the retentive on-delay retentive timer that keep the time, the elapsed time, and does not reset when the input goes to 0 until the elapsed time reaches to the preset, or we reset that with the reset instruction. Okay, these are the timers, and we are going to use these timers, some of them, in implementing the lubrication, bearing lubrication process control system. Okay, here is the process description of the bearing lubrication process. I prefer to read that together, to go through the detail, look at that, to get familiar with the process description. As I mentioned, the program should be based on the process description. So the process description is something that is given to us, and we generally use that process description to calculate, to prepare the program. Okay, so let's read that together. In every process description, generally there's one or two, a few paragraphs to explain the process general, as the general application of that and what we expect on that, but the detail then are generally given itemized. Okay. In this industrial application, there is a machine with a large steel shaft supporting by bearings. This shaft is coupled to a large electric motor, the shaft that is connected from the motor to the gearbox. The bearings need lubrication, which is supplied by an oil pump driven by a small electric motor. The operation of the program can be summarized as follows. Okay, see? So in the first paragraph, just explain what's the general purpose of this process, what is the process, and then it starts the detail. To start the machine, the operator turns SW on, switch that is called SW, turns this on. So we have a switch called SW that the operator turn on and off, turn on that by this, and also generally turn off. Before the motor shaft starts to turn, the bearings are supplied with oil by the pump for 10 seconds. Okay, so we need to turn on the pump, and with a delay, with 10 seconds delay, after 10 seconds delay, the motor starts. The bearing also receive oil when the machine is running. So during the running the machine, the bearing continues. When the operator turns SW off, switch off to stop the machine, the oil pump continues to supply oil for 15 more seconds. So when we apply the stop, the machine stops, but let's say the main motor stops, but the oil pump continues for 15 seconds. The total running time of the pump must be calculated. When the total running time is 3 hours, the motor is shut down and the pilot light is turned on to indicate that the filter and oil need to be changed. So that oil, the total time the total running time of lubrication are limited. After sometimes, in this example, 3 hours, after 3 hours, we should change the oil. This is a heavy duty system. Of course, generally it's not 3 hours for this type of process. It is a special example, but it could be, for example, maybe 30 hours, 300 hours, something like that. The same as the cars that we should change the oil after sometimes. A reset button is provided to reset the process after the filter and oil had been changed. So this is the general structure of the process description. We're going to see the program of that, the program to implement this bearing lubrication. But do you have any question? Any question on the timer or on this process description? Okay, the inputs and outputs that are required are these. We need a switch, give a switch to operator to turn on and off. And also we need a reset push button that when the oil changes and the filter changes, operator push that momentarily to reset the whole process, or let's say reset the timer so it is ready for the next time that turning on the pump and the motor. For the output, we need a command to the pump, we need a command to the motor, and also a pilot light. Here we assume that the overload sensor, because generally the electric motors also, especially this one, maybe for the pump not is not that important, but for the motor it is very important to also check the current passing through that. If there's an overload, the motor should stop. So that overload is just something that is in parallel with, is in series with the motor. Maybe we use this also as the input. So instead of having them here, we have them here as the input. And when there's an overload, we stop the motor. This is something that like overheat that we're starting in the overheat, the heater system, the heater program. It was in, I think, lecture number 2. Or maybe number 2, I guess. The heating system, it has an overheat. Similarly, this is an overload that measure the current passing through the wires, wiring of the motor, and then if there's an overload, it stops the motor. But in this example, they are here on series with the motor, so we don't need to take care of them in the program. Okay, the program is given here. Let's look at the program and then see how it works, and then see the simulation of that, and then work with that with the TIA. This is the program. Here you see that we have, of course, the program is continued to this point. Here we have an on delay, an off delay, and on delay retentive. So these 3 types out of 4 types of 4 timer types, 3 of them are used in this program, and you can see how they works. So here we have an on delay and off delay. This is the on-off switch that is given to the operator. Okay, let me mention something. In this diagram, we assume that okay, the operator, there's a switch, physical, mechanical switch to turn it on and off. But we don't need that because we have the HMI. If you have the HMI, we can have some diagram like let me show you here. Okay, we can just simply have a switch here for turning on and off the process, or a button here in the HMI to turn it on and off, to reset that. So we don't need a mechanical one. If we, let's say an external, switch or an external push button. So we don't need to have input, to use some inputs for them. We can use memory variable and save some inputs on the PLC. So a memory is used here. Okay, memory 100. So on off is this one. What is this? This is something that I will look at that in the continue. But this, in fact, is the output of this timer. The output of this timer, this pump running timer. Okay, pump running timer. The output Q. Initially, it is 0. Initially, it is 0. It is a retentive timer, and in the retentive timer, you see that the output is 0 until the elapsed time reached to the preset time. So initially, it is 0. So here you see that at the beginning, this is 0, this is 0, and since this is 0 at the beginning, this is 0, and since this is a normally closed contact, so this is 1. And if the operator apply the command to this to make it 1. Let's say this becomes 1, and as a result, this becomes 1. Then the input instruction of both on delay and off delay timers turns off. Okay. The on delay timer, in fact, is the delay that here you see it from the title, motor starting delay, but for the off delay, it is pump off delay. Okay, what will happen? When this becomes 1, this is an on delay. Since this is an on delay timer, the output of this timer becomes 1 after the elapsed time reached to the preset time. And the preset time is 10 seconds. It means that when you turn this on, let me draw that here. This is the input. Okay. The Q turns on with some delay after 10 seconds. After 10 seconds. Okay. This output, the output of this timer, motor starting delay timer, is used here. Motor starting delay Q. Okay, this is used here. So at the beginning, this is 0, and this is used to command the electric motor. So the electric motor turns on when this is on. The electric motor, the main motor. The main motor turns on when this is on. Then we turn on the process. When the operator switch this on, the motor is still off. For after 10 seconds, the motor turns on. So the motor turns on with some delay. What about the pump? The pump. The pump timer is an off delay. Let's look at the diagram of the off delay. For the off delay, as the input turns on, the output turns on. There's a delay on turning off. So as this turns on, immediately the pump turns on. So this is the motor, and this is the pump. The pump immediately at this time immediately turns on. So the pump turns on. Let's say the output of this turns on, and this is used to generate the command to the pump. So as the operator requests or apply the on command for the whole process, the pump, the oil pump turns on immediately, but the motor turns on after 10 seconds. This is something that we expect. 10 seconds lubrication, and then the motor turns on. What will happen if the operator apply the off command? Let's say apply the command to turn it off. This becomes 0. As a result, this becomes 0. And so these goes to 0. Both of them. This is an on delay timer. For the on delay timer, let's look at that again. For the on delay timer, as the commands becomes the input becomes 0, immediately the output becomes 0. So as this becomes 0, let's draw that here. Let's assume that it turns up. Okay. Turns off at this time. Immediately the motor turns off. The motor immediately turns off. But regarding the pump, this is an off delay. For the off delay, the output turns off when you have it, when you turn. Let's look at it. When the input goes to 0, the output remain on for the elapsed time, for the preset time during the preset time, and then turns off. So there's a delay, off delay. So this turns off with some delay. This. And this delay is given here, 15 seconds. So after 15 seconds. So it turns on, the pump turns on immediately, but turns off with some delay. The motor turns on with some delay, but turns off immediately. So before starting the motor, the pump, the oil pump, is on for 10 seconds, and after stopping the motor, the pump continues to run for 15 seconds. So this is the first part of the requirement. The second part was regarding the time. Any question at this point? Any question? Okay. But there's one more to implement this part. The total running time of the pump must be calculated. So we need to calculate the total running time. Let's assume that this runs for, I don't know, 4 minutes, for example. So at the end, it is 4 minutes plus 10 seconds plus 15 seconds. This is the total time. But again, sometime later, it again turns on. Again, this turns on with some delay, and this turns on immediately. And then when it goes off, again, this goes off and this goes off. The total time that the lubrication system works must be calculated. And if that time, the total time, total running time is reached to 3 hours, this is the process should stop, and we should have some indicator to the operator that, okay, to indicate that the oil change, they should change the oil and the filter. To do that, to implement that, an on-delay retentive is used here. Here you see that, that's an on-delay retentive. The input instruction is connected to the pump. So every time that the pump is on, this is 1, the input becomes 1, and for the retentive, you know that every time that, all the time that the timer is on, during the time that the timer is on, the elapsed time increases. So all through the time that the pump is on, the output, the elapsed time output of that retentive timer increases. If the total time that the pump is on reaches to 3 hours, then the system stops. And this is something that is implemented here. You have 3 hours, the time, the whole preset time is 3 hours. So every time that the pump turns on, the elapsed time increases. If the elapsed time reaches to 3 hours, then the output, let's look at that, the output becomes 1. The output of this timer becomes 1. What will happen? Okay. This output first is used, this is the pump running time, the output Q. This is used here. When this becomes 1, this becomes 0. And so the timers, the motor stops, and the pump also stops, but after 15 seconds. So then if the total running time reaches to 2 hours, the process stops. The motor stops, and the pump also stops with some delay. In addition, this output is also uses to activate some pilot lights to the operator. So the operator knows that, okay, why the process stops. It stops because the maximum duration to use that oil, reaches, and so they should change the oil and change the filter. And when they change the filter and then change the oil, then the system can stop. But so there should be some switch so the operator, let's say, inform the control system that I have already changed the oil and the filter. That is the reset push button. So this reset push button is here. So when they change the oil, when they change the filter, the operator push this push button to give this information to the control system that everything is fine and the process can start again. So what should happen in the program? In fact, we should reset this timer. This timer reaches to 3 hours and stops the process. So we should reset this timer. So the reset, there's a reset condition here. This reset condition is generated based on when operator push the start, the reset push button. Also, you see that the normally close of the on-off HMI. What's the use on-off switch, let's say? Let's assume that for a while that we don't have this. We don't have this for a while. Just assume that we don't have this. When operator push this reset push button, this activates, this becomes sets to 1, and as a result the timer resets. When the timer resets, Q becomes 0, and so again this becomes 1, and so we can turn on the motor. That's good. But the problem is that let's assume that the pump turns off, okay, but the switch is still on. That's a switch. Operator, this is not a push button. Please notice, this is not a push button. It's a switch, a selector switch or a toggle switch. So the switch is still on. The switch is still on, but the system stops because 3 hours we reach to that 3 hours. Then the operator goes, or let's say the technicians goes and change the oil, change the pump, the filter, and they just want to inform the system that everything is good, and they push this. What will happen? This becomes 1, this resets, and this becomes 0. This becomes 1, and please notice that this is still on because it was on and nobody changed this to off. What will happen? The motor starts immediately. So when they change the oil and when they change the filter, they just want to inform that everything is ready and you can start working with that. They just push the reset push button to inform the operator, to inform the control system that the oil has changed. Without this part, without this contact, the motor starts immediately, and this is very dangerous because who knows, maybe somebody is working over there or they don't know that, okay, the system is going to start. So this is here to be sure that this timer resets only if the operator pushed the reset, but also the on-off switch is in the off mode. So if the on-off switch is not in the off mode, if this is in the off mode, okay, so it means that this is 0, and then this is 1, and then when the operator push the reset condition applies, the timer resets, this becomes 1, but this is off. This is off, so the motor does not start. Otherwise, the operator goes and start the system. This is very important. This is because of the safety. It is not mentioned in this process description, but this is important from the safety. Of course, we should check if we see that and say that, okay, without that, according to my program, if we forget to have this, after analyzing, as I mentioned, we should analyze different scenarios. Try to analyze what will happen in different scenarios. One of the scenarios is, okay, what will happen when an operator push the reset? According to this program, everything starts immediately, even before the operator requested to turn it on. So we should check with the process specialist, but generally this is something that they expect. They expect that, okay, when you change the oil, do not start. Inform us that you have already changed, but do not start the process because generally this oil change is something that done by some technicians that do those changes, but the operators has the permission, should apply the command to turn it on, to turn the process on. So this is because of that. This is the PLC program. The HMI, we will look to the program on detail, but the HMI, in fact, in this HMI, in fact, we are going to have practice on having multiple screens. So 2 screens, not just 1 screen. In the main screen, this is the main screen that, okay, we have the pump, we have the process. Two things to practice in this HMI. One of them is to have multiple screens. The other is that to add some photo, or some object, some picture object to the HMI instead of building them, because it's very difficult to build some objects like this, but we can have some pictures added to the HMI. And this is the main screen. So operator looks at see this when they turn it on by pushing this by selecting the pushing this button. The process starts, and this oil pump starts. After 10 seconds, the motor starts, and then they stop. The motor stops after 15 seconds. This stops. Okay, and this is the reset button. But sometimes maybe operator wants to know how much has already elapsed. It has not yet reached to the 3 hours, the final time, the preset time, but they just want to know how much is that. We can have the elapsed time here, but this is not the information that normally operators need. They don't need that normally. Maybe sometimes they need that. So you can generate, you can create another screen. In that screen, the elapsed time is given. The elapsed time is given in the screen, in that screen. Every time that operator wants to see how long it changes, push this button, push this by, and this is just a touch screen. So push this, and then this screen opens, and they can see that, okay, how much is the let's say oil usage lifetime, or the elapsed time for that oil usage lifetime, how much is that? And they can go back. And also there are some message that this message activates when when it is the time to change the oil. So by red, and maybe by signaling or something like that, by flashing, it highlights or indicates to the operator or inform the operator that they need to change. Okay, this is the general structure of the program. Let's look at the program itself. Okay, let me close this. Any question? Okay, so browse, submitted. This is the version that I uploaded for you, bearing lubrication. Okay, open this file. Before working on that, I just want to be sure that I don't forget to mention that tomorrow you have the quiz. I will send another announcement to remind the quiz. You take the quiz in the Moodle. Let me show you. Where's that? Okay, where's the Moodle? Oh, where's that? Okay, let me open a new. Okay, just to be sure that you know how to take the quiz under lecture 6, because we postponed the let's say we keep the time for the quiz, which was supposed to be on lecture 5, but because of this early lecture, so we have that on lecture 6. So you see that under lecture 6, there's one. This is just a pretest quiz. This is not the main quiz, but the main quiz also will appear here. The main quiz also will appear here. This is the pretest quiz. Of course, so click on that, open that. For me, because I'm the instructor of this process, maybe the detail of this window is slightly different from yours, maybe, but it is something like that from for you, also like that. So for me, it's written preview quiz because I'm not going to take the quiz. I'm going to preview the quiz. But for you, it is, I think, starting the quiz or something like that. So just start that. This is the same, okay? Start that. And then the quizzes are appeared. If there are multiple questions, that will be, you can see multiple choices here. But for example, this is the question number 1. It's just a dummy, simple question, not any special question. It's just for practice. So for example, this is a test question, okay? Select the correct answer. The word PLC starts with L, it starts with M, starts with C, it starts with H, or starts with P. Okay, that's just a dummy question. The word PLC starts with P. You select that, okay? And then continue to the next example, the next one, and then continue to the next, and then when you reach to the final question, if everything is fine, then finish the quiz. For me, it is written finish attempt, because it is so finish attempt. When you click on the finish attempt, it again show you, okay, if you have already answered the quiz or not. If everything from your side, everything is okay. So answer saved, how many questions the answer are correctly saved. Maybe for some reasons we forget one of the questions, or we didn't select any answer. Then everything is good. You can return to the attempt. Okay, you can return to the attempt and then again change any question, any answer. And then finally, if everything is fine, submit all and finish. Click here. And again, to confirm, submit all and finish. And then immediately you will have your result, whether it is correct or not. And what is your grade on that one. Let me start a new preview, and this time select the wrong answer. For example, this one. PLC starts with L, for example. This is a wrong answer. Again, there are multiple questions. Let's assume that finish attempt. And then again, submit all and finish. It indicates that the selection is not correct. It is green, and also the grade is 0. Also, what is the correct answer? So please just check this pretest quiz. Just check this pretest quiz to be sure that you know how to use, how to take the quiz. And then at the time, tomorrow at 5:30, right at the end of the lecture, you can, the quiz starts. So the quiz starts at that time. And yeah, and the quiz will be exactly at here, at lecture 6, okay? Will be after this. This is, I keep this pretest quiz for you to check, but there will be another quiz here, quiz number 1, that you should take that as the test. This is just for your practice to be sure that you know how to use this quiz on the model. Any question on this? How to use that? Okay. So let's open this program. This is for the bearing lubrication. This is the program that you have, so you can open that. It's written in version 14, so if you have already downloaded version 15, or later get the version 17, you can open this, but it just asks you to convert, whether you agree to convert. Let me open, increase the size. Okay. Here, for example, you see that 10 seconds. If you're going to change, for example, let me say 1 hour underline 10 seconds, for example. Okay. This is simply changed, but don't forget T sharp. And then, so this is the program. Nothing special on the program. We have already checked that, but I want to show something on the, again, Detail on how to build this program is given in recorded version for this lecture. For the recorded version of this lecture, I mentioned that this recorded version of this lecture was very noisy, and I'm going to replace that. So I have not yet uploaded that. Tomorrow I will go to prepare a new video for this preparing this program and upload that later. But the program is here, and for the HMI, okay, for the HMI, okay, you can see that we have two screens, the root screen and screen number 1. Of course, you can change the title. Let's look at the root screen. In the root screen, you see that I added the pictures for the pump and the mill, and also selector, this selector switch from here, this switch from here, and also presets. And then there's another screen here.
Excuse me.
Yeah.
It's what it's saying. I was not seeing the screen.
Oh, you cannot see the screen?
Now I can see it now.
Oh. Now, can you see now?
Yes.
Okay, very good. Okay. So in the screen number 1, the next screen, it just shows the lapse time, and this is something that is coming from here, this value, and then okay, let me open the properties of that. Okay, this one, the properties of that, and in the properties here, you see that it is connected to oil use duration. Oil use duration is the timer that we had, the output of the timer that we had for that, for the what was that? Let me show here. Yeah, for this one, oil use duration. You see that this output. So it is connected to this elapsed time of this retentive. So it shows this oil use duration, this MD13, as the variable for that. So it is connected to that. Also for the screen, the main screen here, you can see that, as I mentioned, since the detail on how to create that is given in the recorder, I'm not going to go through all the details on that, just show you a few and then run that. I want to run that to see. Here, there's a button. This is this button, okay? This button, it is this button. And then you see at this button, for the events on that, on the click, okay? On the click, the screen number 1 opens. So every time that we click on this button, this box, every time that we click on this box, the screen number 1 opens. So this is, if operator wants to see the elapsed time or the duration or the usage of the oil, just simply click on this button, on this square, and then screen number 1 opens. In the screen number 1 again, let's see that. Again, okay, the elapsed time is given. And then there's a back button, another button, that this button is also, when you click on that, activate previous screen. So automatically it's returned to the previous screen, and the previous screen was the root screen. So simply we can have multiple screens, and depend on the situation. It is a general practice in HMI that you have a root screen that has the main devices and main variables or main informations, those that operators need to know them most of the time. Look at them and like that. But if they know, if they want to know more on the detail on some part, they can click on that, open that with some by clicking on some like this one, by clicking on this button, and then a new screen opens, and that screen you have more information. Okay, let's look at that how it works. But just let me mention something here in the program that, okay, 3 hours is, of course, this is 3 hours is needed, but I just changed that to 120 seconds to make it shorter, so you can check that during this session. Okay, so let's simulate. I have already explained the simulation, how to do simulation and upload the simulation and run that and upload a file in the lecture number 1 together with the configuration, of the PLC, of the HMI, and then another one for the PLC sim, how to use the PLC sim. So please look at that. But anyway, this is the program. Let me check to be sure that there's not any error on that. So compile that, click on this to compile. There's not any error, that's good. And what about the HMI? Let's check the HMI also. HMI. Oh, okay, there's not any error. Okay, there's not any error on that, that's good. So let's download. Download on the PLC sim. To download, if you're going to download on the PLC, as I mentioned, okay, we should click on this to download to device. But for simulation, we click on this one, start simulation. So let's start simulation. Okay, this is the faceplate for the PLC simulator. Run mode, stop mode, or turn it on and off. Let me, this has already downloaded. Oh, yeah, not yet. Okay, not yet. It is not yet. Okay, yeah. Okay, nothing special happened here, so there's not any error, so load. You see, during the load, to load the program on a PLC, it should be in the stop mode. In the simulator, you can see also it is in the stop mode. In the real PLC, it asks you generally to stop the PLC or not. In the simulation, that's not a problem. It automatically stops that. But in a real PLC, when you have the physical PLC, it does not stop that automatically, because maybe by a mistake you push the load, or maybe the process is working. We should stop the process and then load the program, or we should take care of that anyway. Maybe we say that, okay, that's fine, just stop and load the program, but it is something that maybe there's something dangerous happens in the real process. So it asks a permission to stop the PLC. But in the simulation, generally, it doesn't ask any question, it just stops the PLC. But when the program is downloaded, it then asks whether you want to start the PLC or not. Yes, start that and finish. And so automatically it switch to the run mode. And so the PLC is running. To be sure that the PLC is running correctly, click on this, monitor on off, to see the state of the variables in the program. Here again, you see that, okay? So the blue and green shows, or the values here shows the value of them. Okay, so it is running. This is 1, but this is 0, so it is not. Okay, to apply the command, we need also to open the HMI. So let me drag it here, and then open the HMI and simulate the HMI. Let's simulate the HMI. This time, start simulation for the HMI. For the HMI, it just starts. It doesn't ask you any general question. Otherwise, there's a need for the configuration. But this is the HMI. This is the main HMI, okay? So the pump, the motor, and the on-off. Let me click on this on off. You see, as I start that, the pump, by the green, it shows that the pump is on. And also the pump, it is there. After 10 seconds, the motor also starts. See, after 10 seconds. And it remains on until you push the stop. Let me push the stop, or let's say apply the command to stop. You see that the motor stops immediately, but the pump continues to run for 15 more seconds. Let's see, after 15 seconds, this also stops. Okay, it stops. Again, another time, let's turn it on. Again, this turns on, and after. If you don't want to know how much is the elapsed time or how much is the oil usage time, double click here, okay? And you see that a new screen opens. Not double click, just click. This starts. And you see that the elapsed time is given in time. When this reaches to 120 seconds, and then you can go back. When this reaches to 120 seconds, it is the time that the oil should change. Let's see what will happen. It takes time. So you can see, simply you can go to this, you can switch between the screens. Let me just stop that again. Okay, stop to see that once more. After, and here you see that it is still running for 15 more seconds. And then after 15 more seconds elapsed, it should stop. Yeah, this stops. This is the time that the pump is also stops. So it's okay. So let me start that again. And this time we reach to that 120 seconds. Let's see what happens. Will happen at that time. Okay, this turns on. It is not yet 120 seconds. Okay, you see that when the 120 seconds happen, reaches, the system stops. Of course, first the motor starts, and after 15 seconds, this also stops. Although this is on, and there's an indicator here: oil change oil and filter. With flashing, it highlights this information, this message to the operators that it's time to change the oil. You may have some also pilot lights, or you may have also some horn or some buzzer. Let's say generally buzzer in this case, a buzzer to indicate to the operator that okay, that's the time. Here it's just this one. Let's open the screen. You see that also there's one message here, 120 seconds, and so there's a message here. And let's assume that somebody goes and change the oil and change the pump, change the filter, and then push this reset. Nothing happened. Why? It's because this is in on mode. It should be in the off mode. This is something for the safety we put. If we didn't use that safety contactor over there, when we push this reset, the whole process starts. The pump starts, and then this meal, and this is dangerous. So it should be in the off. When it is in the off, and then we push the stop, the reset. Okay, this resets to 0, and it is ready for the next round of operation. Okay, this is the whole program. The detail is given in the recorded, so please watch that to see how to create these. Of course, I'm sure that you can make more beautiful and informative HMI. These are just simple HMI to see some of these instructions, the main instructions. For example, in this case, I wanted to show you how to add a picture and also a new screen, how to go back and change from these screens and like that, and also an indicator for the error. But I'm sure that you can make more beautiful and informative screens. Okay, let's stop. Let me also stop, go offline. It's better to go offline and then stop the PLC. At least for my computer, sometimes hangs. It sometimes hangs, so I recommend to stop and go offline and then stop. Yeah, stop that. That's everything is okay. Okay, any question? So please don't forget to, have you downloaded the PLC program? Could you download the program from the Siemens and start working using that free version? They have not yet get that license key. We're waiting for the license key. It will be available, I hope, hopefully this week, but we have not yet received that. As they deliver, we will send them to you. But meanwhile, during this time, you can use that 21 days free version of that. Have you downloaded? I just want to be sure that everybody has the program and starts working with the program. Or if you have any difficulty on downloading, I don't know, creating the account or downloading, or even the installation is not very difficult. It's just go to the default. Just simply there are some questions regarding license, regarding where to install in your program. This is your choice, so you can select change them, but there's not any special change from the technical point of view. So just simply follow the installation. But if you have any question, please let me know. So please let me know if you had any difficulty on downloading, on installing, or starting working with the PLC, the TIA portal. This is very important that all of you works. I'm thinking about maybe, I don't know, when if you have any question, we can have some meeting to, if you have any difficulty on working with the portal, we can have a meeting, face-to-face meeting through the model to check what's wrong, if there are any difficulty for you to start working with that. The detail on how to program are given in this recorded version. So check that. If you you have any question on those, let me know. But regarding installation, that I also give the information regarding where to find, how to find those software, the PLC software, and downloading and explaining the installation in that new recording regarding the PLCC. That recording. So please watch this one. Let me show you. In the lecture number 1, you had these two. Part 1 was a PLC, not PLC. This is PLC configuration. I should correct that. This is PLC configuration. This is HMI configuration, and a new recording is added for part 3. TIA software download and simulation using PLCC. This one. Please watch this to study how to download the TIA software and then start using the PLCC. Please watch this and let me know if you have any question. Okay. Any question?
When we expect the quiz come in?
The quiz? The quiz will be tomorrow at 5:30.
That is 5:30 the Kenyan time.
Yeah, Kenyan time. 5:30 p.m. at Kenyan time, and it is available in the Moodle. So you open the Moodle, go to lecture 6. Let's review that together. You in the Moodle, of course, this is my details as I see. Maybe you see a little bit different, but it's almost the same. So under PLC, I don't change that to today because this was an extra time, and maybe somebody had a difficulty to come to at this session. So I keep that for tomorrow. Here, after the homework, you will have the preset, the quiz. Here, right now, you have just a preset quiz. This is just a practice. Just do practice to be sure that you know how to use that. But then there will be another icon here for the quiz number 1, which you can start. It is available at 5:30. And then you can start your quiz. But please, meanwhile, check your system to be sure that you know how to take the quiz by clicking on this pre-test quiz and follow that. That's a simple 1 question just as a practice to know how to do to take the quiz. So please don't forget to take this to be sure that you know how to take the quiz. And then at 5:30, you have another quiz here. This is another icon here for quiz number 1, another link, sorry, for quiz number 1. Click on that and start the quiz.
Okay, that is tomorrow after the class at 5:30.
5:30 Kenyan time. Yeah.
Okay,
Right after the class. Right after the class.
Okay.
You have the class from 4 to 5:30, and then from 5:30 you have you start the quiz.
And maybe on the same quiz, is it going to be timed, or we can do it anytime from 5:30?
No. You should do that at 5:30.
So for how long?
15 minutes.
Okay.
Okay. It's not that difficult, but it is some limited time.
Okay, that's fine.
That's fine. Okay, any other questions or comments?
Maybe just a comment on what you covered so far.
Sorry?
I just want to say a comment
Okay.
based on what you've done so far. I think the lectures have been so very good, and I personally want to appreciate you for always being there on time. Mm-hmm. For us students, sometimes we face network problems, but you're always there.
Yeah.
Like today, you are there at time, and maybe majority of us were not there, but you keep on trying and really doing it well. You must appreciate that, and you say thank you, and may God bless you and give you that strength to continue helping us.
You're
Thank
welcome.
you.
You're welcome. You're welcome. Thank you very much for your feedback. You're welcome. Really, I want you to study these, and I'm sure that these will be helpful for your future career and for your students later that you're going to work with them. And I like to be with you. So please don't hesitate to anytime that you have any question, email me. And yeah, and also thank you for this positive feedback. Also, I appreciate if there are any negative parts, also let me know so I can improve my.
So far, I don't think there's any negative.
Okay, thank you. Thank you. I'm glad to hear that. I'm glad.
Sir, I missed your email address.
My email address is alireza.fatih. It's given in that orientation. In that orientation PDF, it is alireza.fatih@humber.com. Alireza, let me write that again here. This is my email, so you can simply email me if you have any question at any time. That's in humber.ca. So simply this. Fatih@humber.ca. Yeah, this is my email. So anytime that you have any question regarding the course, please send me an email. Okay. Any more comment or questions? Okay, see you tomorrow at 4 o'clock for the lecture. and we'll continue at 5:30 for the quiz. And the
Thank you. See you.
Yeah, see you. It's based on lecture 2, 3, 4. Please notice, not lecture 1, not lecture 5. Lecture 5 that we studied today is not part of this quiz. It will be part of the next quiz, but it is based on lecture 2, 3, 4, not 1 and 5. Just 2, 3, 4. Okay. Okay, see you tomorrow.
See you.
Bye. Goodbye.
Bye. Bye.
Goodbye.